parallel lines. So please find your notebook, set up your Cornell notes, pause the video, and resume when you are ready for notes. All right, so the first thing I want you to think about today is, since we're talking about parallel lines, what do parallel lines look like? And what do you know about parallel lines? All right, so hopefully when you're thinking about what do parallel lines look like, you came up with a picture like this in your head, not necessarily on the graph, but two lines that never intersect, two lines that will never meet, two lines that will never cross if we extended them forever. In our graph space, we can tell that these two lines are parallel because they have the exact same angle. So I want you to think about what actually makes it so that they have the same angle. And you might notice that I'm drawing the rise and the run, or our slope triangle, on each line. Both lines have the exact same rise of 3 and the exact same run of 5. In other words, they have the exact same slope. So for your notes, parallel lines have the same slope and they have to have different y-intercepts. And they have to have different y-intercepts, otherwise they would be the exact same line. So here are two different equations. And in each case, the slopes are the same, but the y-intercepts are different. Both equations show a slope of 2. One equation has a y-intercept at -5, and the other equation has a y-intercept at 9. And we could tell that just by looking at the equation. We didn't even have to graph the equations to tell that these would represent parallel lines. So we're going to take a look at writing equations of a line that's parallel to this given equation, y equals 1/3 x minus 8. And we also know that this other line that we're trying to write the equation of goes through the point -6, 2. So what we have to do is put some information together to try to write this equation. So I want to actually take it over to the graph so that we can get a visual for what's happening. So I'm going to start by graphing line number 1. Y equals 1/3 x minus 8. And in that equation, I can see that my slope is 1/3 and my y-intercept is -8. So on my graph, I'm going to start at -8 on the y-axis, and I'm going to plot more points using my slope. Remember, slope is rise over run. So my fraction tells me that I want to rise 1 and run to the right 3. Rise up 1, run to the right 3. If I work backwards, I then go down 1 and back 3. And I would get a line that looks something like this. There we go. Now, what we're trying to do is actually draw this second line. And all we know right now about the second line is that it goes through the ordered pair -6, 2. So I can plot that point on my graph. But I also know that it has to be parallel to the first line. And we just said that parallel lines have the same slope. So what was the slope in the first equation? 1/3. So I want to draw a line that has the exact same slope. A rise of 1 and a run of 3. I use my slope to plot multiple points. And I can see that these two lines are, in fact, parallel to each other. They have the exact same slope of 1/3, and they have different y-intercepts. And we can even tell that the ordered pair -6, 2 is on the line. So how do we do this without graphing? So without graphing it, it's a 3-step process. We identify the slope of each line. We write the equation of line number 2 in point-slope form. And then we go ahead and convert that to slope-intercept form. So let's do that. Line number 1 had a slope of 1/3. We got that from the equation. It also had a y-intercept of -8, but you know what? We don't even use that. Line number 2 has to have the exact same slope because that's what parallel lines have in common. They have the same slope. So they both have a slope of 1/3. Step 2 says to write the equation in point-slope form. Well, the reason why we use point-slope form is because -6, 2 is a point, and 1/3 is the slope. So it would make sense to use point-slope form. That's the long one with the parentheses. Y minus blank equals blank times x minus blank. Our slope goes after the equal sign. Our x coordinate goes inside the parentheses, remembering that a double negative here is going to change it to an addition sign, x plus 6. And then the y coordinate was 2. That's point-slope form. Done. Step number 3 is to convert to slope-intercept form. To do that, we have to distribute the right-hand side. So we distribute the slope, and we get 1/3 x plus, let's see, 1/3 times 6. We do 1 times 6 divided by 3. That gives us 2. 1/3 of 6 is 2. I'm just going to bring down the left-hand side. And then finally, if I want to get slope-intercept form, I have to get y by itself. So I want to add 2 to undo the -2 so that this cancels out. That will leave me with my final answer, the equation in slope-intercept form, y equals 1/3 x plus 4. So I want to go back to the graph for a moment. If you need to pause the video to copy that down, please do so. I'm going to go to the graph next. Remember that equation, y equals 1/3 x plus 4. Y equals 1/3 x plus 4. So if we look at our graph here, we should see that the line has a slope of 1/3, which it did, right? A rise of 1 and a run of 3. And we should also see that it has a y-intercept of +4. And if we check on our graph, it crosses the y-axis right there at +4. Okay, so the graphing is just to give you a visual representation of what we're trying to do, but algebraically, this is what we were trying to do. Use the slope in the first given equation to find the slope of the second equation. Because they have to be the same, we can use that. We use the point that was given in the example to write a point-slope form equation and convert that into slope-intercept form. Let's try that on a second example. So here we have, find the equation of a line that is parallel to y equals -x minus 8 and goes through the point 3, 5. So keeping in mind, if it's y equals -1x minus 8, my slope is -1, my y-intercept is -8, which I don't need. Because I'm working with parallel lines here, these two lines have to have the exact same slope. So I use the same slope of -1, but I don't know the y-intercept of my second line. Instead, I know a point on the line at 3, 5. So I'm going to write a point-slope form equation where my slope was -1, my x-coordinate's 3, my y-coordinate's 5. Now I want to transition this into slope-intercept form. So I do a little solving. Distribute on the right-hand side. I get -1x plus 3. I need to solve to get y by itself, so I add 5 on each side. I get y equals, and I know it's -1x, but I really should just write -x. And then I add together 3 and the 5 to get 8. So y equals -x plus 8. So both lines have a slope of -x, and we have different y-intercepts. And that equation, y equals -x plus 8, if I were to graph it, would go through the point 3, 5.